When we talk about persisting data in Android, we talked firstly about how to do that using shared preferences. And last time we talked about pretty extensively about SQLite database and how to save data using databases and tables and so forth. So this is what we more or less saw happening. Of course, the recycle view layout manager, that is more of a user interface, so that's not related necessarily to the saving part of things. But then you see we have the adapter there, which connects to our data set. So the data set would be the meat, what happens when we want to save data internally. Now, this way of saving data using SQLite works fine for smaller applications. Now, when you want something a little bit more sophisticated, for the lack of a better word here, or something more extensible, you can see that using straight SQLite and extending to the SQLite classes that we've seen before to create a database and create tables and then having to name them and do all the CRUD operation, so forth, that gets a little bit old and it's easy to make mistakes. So coding mistakes and something that will lead into having a lot of bugs in our code. That's the reason why they've created what they call the Android Room. Now, Android Room, as you can see here, is represented in this diagram here. This is the hierarchy that it's used in Android Room to do the same thing that we have learned when we started learning about SQLite database handlers and how to create databases and tables and saving data. But this is much better because now we have a structure. Let's go ahead and dissect all of these things around here so we can have a better idea of what's going on. So we have our diagram here and we're going to start from the beginning, meaning the bottom. Now, there's a lot of things here that are very new to us. In fact, the only thing that should be not new to us, should be something that we know, would be SQLite, because SQLite is just a system that is installed inside of Android operating system that deals or knows how to persist data into it. So you can create database and table and so forth, right? But then you notice at the top we have what we call entity. What is this entity? You will notice also now the language is going to change a little bit, but it will mean the same thing that we already know. So an entity in the Android Room realm, it's what we call a table. So in this case, it's going to be a class that will represent a table that we can create and add things to it. And then we have a SQLite, which you know is just a database system installed inside of our operating system, Android operating system. But then to interact with our SQLite here, we have this DAO. What is this DAO? Well, DAO stands for Data Access Object. What does that do? It does exactly what we did before, which was doing all the CRUD operations, creating all the queries, and do all sort of things, right? So if you remember correctly, if you've been following us, we've created before what we call the database handler, which has all those functions you have learned to know and to love, right? All the CRUDs and so forth. So you see, at this point, nothing is really new, except we're just moving things. We are creating a little bit more classes, more entities that will help us connect with other entities within this realm here. Now, all of this is actually encapsulated inside of this main class called Room Database. What is this? Well, the Room Databases allows us then to encapsulate, like I said, everything inside of entity, SQLite, and DAO. So Room Database is where everything is created. So this is where we create the actual database, right? We do all the queries. We make sure that everything is correct. Everything is actually working properly, right? So that is the main base entity when we talk about Android Room, a better way of saving data using SQLite. Okay, so let's look at the top now. So we still have our hierarchy here. We saw at the bottom, and now we're going to look at the top half. So here we have what we call a repository. Well, the repository does something very interesting. It's not a class that is actually given to us. It's something that we create. We don't have to have it, but we create it because we want to have another buffer between our underlying system we saw before at the bottom there and our user interface at the top. So repository is just a communicator that allows us to, whenever we want to do something, we call it, and it itself will go and do all the things that it needs to do at the bottom. So call the room database and do all sort of things that needs to be done, and then just retrieves the data, which will be passed on to our top view model. Now, at the top there, right above repository, you notice we have this view model, and inside of view model, we have something else. Let's talk about this view model. Well, what is a view model? The view model is responsible for getting all the data that it's needed with the user interface so that then can be pushed into the actual activity or fragment or whatever it is that we are showing to the user. Very interesting here. View model, I'd like to call it as another version of activity or just a fragment class, right? So if you remember, activities do have their life cycle, but those life cycles are very limited because the idea of a life cycle is to delimitate or to show that things are going through a process. At the end, they will have to die. That is a life cycle, right? With view model, we still have some life cycles that we can actually invoke and do sort of things, but it has more than just plain activities because at this point here, we are dealing with data. And so when we're dealing with data, we want to make sure that things are actually working because we don't want to get to the point where we are dying, quote unquote, in case of an activity, and we're in the middle of a transaction with data, with our repository, which is getting data from our room database and so forth, and then lose it all. The view model is a little bit more extensible or a little bit more sophisticated in that it understands the whole realm of database creation, of database transaction. So it will always cater to making sure that this data that we are passing around, viewing it, making sure it makes it to our user interface, the actual activity or fragment, it's actually working properly. But for that, it needs help. It needs help of another kind of entity that will allow it to say, okay, as I'm getting this data, this is the view model, okay? As it gets its data from a repository, it needs to wrap it around this new entity, this new object that will know how to then see what's going on at the top with our user interface, whether it needs refreshing or not. Now, this entity, this object, this new class that we given here, right, with the Android room, is what we call live data. As the name implies, live data so allows us to encapsulate or to wrap our data that we're getting from a repository and then attach to our view model so that if something changes from our repository, it will know what to do, meaning it will go ahead and get the data and refresh everything or update everything so that it serves new data that it's supposed to serve. So live data, it's an abstraction that inherits or implements what we call an observer. So as the name implies, live data, it's supposed to be live, meaning it's supposed to be searching around, always listening around of whatever is happening around it, meaning all of other classes that are connected to it. If something changes in the user interface, it will know how to then take the data, the new data that was fed to it, to the view model, and then do what needs to be done and then pass it along so that the user interface can take that data and show right away. So that concept, observable, is a very powerful concept. In fact, is one of the Java design patterns, which I will show you at some point so you can really understand the power of observables, because it allows us to create a lot of very dynamic systems that they're constantly listening, right? There's somebody who's emitting something and somebody who's receiving something, right? This observable or observer will always be listening to whatever changes that are happening and then will react instantly, which makes for a very dynamic application. Okay? All right, so that is indeed Android Room. I have to be honest, at some point I thought maybe it's not a good idea to introduce Android Room because, as you can very well attest, it can be a little bit intimidating at first. But I thought really hard and took the time to put together this little presentation here because I want you to understand that everything is hard at first, right? Especially if you haven't heard it before, if it's new to you, everything new is hard because you don't know it. But I hope that with this little presentation, you're able to at least conceptually see. You may not understand everything, obviously, but at least you can start seeing the value that we have now. Number one is that we have a structure, right? An architecture, a structured way in which we can create scalable classes or scalable databases in our applications, as opposed to doing the way with database handlers where we had to code everything ourselves, okay? We still have to code things here, obviously, but it's different because now we're backed by the system, in this case, Android Room. Right? So here's another thing. You probably are used to this by now. If this is not making much sense now, one thing I would like you to do is rewatching this video. We are going to build a full-fledged app using the Android room so I can show you exactly all of these things that you've seen here, right? All in practice. I hope you're excited as I am, and I will see you in the next video.